Dear students, greetings for the day. In the previous classes, we discussed the units and dimensions and friction in first chapter, in which we know the definitions of the unit, types of physical quantities, and examples for fundamental physical quantities, derived physical quantities, and in second chapter, we discussed about the different types of vectors and addition of vectors, subtraction of vectors, multiplication of vectors, and triangle law, polygon law of vectors, parallelogram law of vectors, and about the properties of scalar product and vector product of vectors. Now we discuss in third chapter about dynamics. This dynamics is important branch of physics which deals with the motion of the bodies. So this dynamics is mainly divided into three types: kinematics, kinetics, and statics. So kinematics is the branch of classical mechanics that describes the motion of points, objects, and systems of groups of objects without reference to the causes of motion, that is forces. So here we discuss only about the initial velocity of the body, acceleration produced in the body, and distance traveled by the body, and final velocity of the body. But here we do not consider either masses of the bodies and forces of the bodies, that is forces acting on the bodies. The study of kinematics is often referred to as the geometry of motion. Objects are in motion all around us. Everything from a tennis match to a space probe flyby of the planet Neptune involves motion. When you are resting, your heart moves blood through your veins. When in inanimate objects, there is continuous motion in the vibrations of atoms and molecules. Interesting questions about motion can arise. How long will it take for a space probe to travel to Mars? Where will a football land if thrown at a certain angle? An understanding of motion, however, is also key to understanding other concepts in physics. An understanding of acceleration, for example, is crucial to the study of force. So, in this kinematics, we come across with the words rest and motion. Generally, any body must be either in rest or in motion. If the position of the body does not changes with respect to time and surroundings, then it is said to be in rest. If the position of the body changes with respect to time and surroundings, then it is said to be in motion. So to describe motion, kinematics studies the trajectories of points, lines, and other geometric objects, as well as their differential properties such as velocity and acceleration. So when body moves, it is present at different positions at different time intervals. So when we join the positions of the body at different time intervals, we get the path or trajectory traveled by the body. So trajectories means the path of the particles traveled by the body or particle. So Here, the total length of the path is called distance. And distance is a scalar quantity. It is measured in meters, we know, in SI system. And it is measured in SI system in meters. And dimensional formula is L. Whereas similar term displacement. So when the body travels in a particular direction, then the line joining the successive positions of the body from starting point to end point, then that line refers to in a particular direction, then it is called displacement. So total length of the path in a particular direction is known as displacement. It is a vector quantity. It has same units and dimensions like distance, that is meter in SI system. So SI unit is meter in SI system, and dimensional formula is L. When body position changes with respect to time, then if it is do not possess a specific direction, then its change in position of the body is called distance. And if the body changes its position in a particular direction, then it is known as velocity and displacement. So the rate of displacement is called velocity, or distance per second is called speed, whereas the displacement per second is called velocity. Whereas speed is a scalar and velocity is a vector quantity. And both have same units and dimensions, that is meter per second in SI system or NK system. And dimensional formula is LT to the power minus 1. Already we know this one. So when the velocity of the body does not change, and if the body travels with constant velocity or uniform velocity, then its acceleration is 0. If the velocity of the body increases with the time, then it is said to possess positive acceleration. If the velocity of the body gradually decreases with time, then it is said to be possessed with a negative acceleration. Therefore, velocity is also said to be two types, uniform velocity and non-uniform velocity. If the position of the body changes, if the changes in displacement are equal in equal intervals of time in a particular direction, then its velocity is said to be uniform. If the displacements covered by the body in equal time intervals is not equal, or direction is changing, then its velocity is said to be non-uniform. So acceleration is also said to uniform if the changes in velocity are equal in equal intervals of time, then it is said to be moving with uniform acceleration. If the velocity of the body does not change with respect to acceleration, with respect to time, then its acceleration is said to be non-uniform. Kinetics is used in astrophysics to describe the motion of celestial bodies and time systems, and in mechanical engineering, robotics, and biomechanics to describe the motion of systems composed of joined parts such as an engine, a robotic arm, or the skeleton of the human body. A formal study of physics begins with kinematics. The word kinematics comes from a Greek word kinesis, meaning motion, and is related to other English words such as cinema, movies, and kinesiology, the study of human motion. Kinematic analysis is the process of measuring the kinematic quantities used to describe motion. The study of kinematics can be abstracted into purely mathematical expressions which can be used to calculate the various parts. and aspects of motion such as velocity, acceleration, displacement, time, and trajectory. Kinematics is the study of motion of mechanical points, bodies, and systems without consideration of their associated physical properties and the forces acting on them. The study is often referred to as the geometry of motion, and it models these motions mathematically using algebra. The systems in kinematics are modeled to calculate such things as speeds and ratios. An example model of bodies in a system is the gears in a vehicle's transmission. These models are used to engineer all manner of mechanical devices and to model the motions of existing physical bodies, including the motion rigid body rigid mechanics of the human skeleton or the motion of celestial bodies in astrophysics, which is also known as stellar kinematics. Kinematics is very useful in the conceptual design of mechanical systems. Initial geometrics and velocities of bodies are a part of the model. While kinematics can help to determine whether a design is theoretically possible, there are more complexities when designing something for the real world. Without consideration of materials and the forces acting upon them, many theoretically possible designs would be prone to failure. Kinetics, in contrast to kinematics, does consider the physical properties such as the mass of the bodies or the forces driving them. Kinetics is logically reduced from kinematics by way of algebraic calculation of physical properties and forces. Kinetics takes into account physical forces and properties including material properties like mass, rigidity, and tensile or comprehensive strength. These properties, coupled with physics and thermodynamics, can take a theoretical model from kinematics and help determine how to engineer a viable, reliable, and functioning real-world system. Now, we know about already displacement, distance, velocity, acceleration, time, speed. So, before going to equations of motion, we know that motion is the state of change in position of an object over time. It is described in terms of displacement, distance, velocity, acceleration, time, and speed. Jogging, driving a car, and even simply taking a walk are all the examples of motion. The relations between these quantities are known as the equations of motion. In case of uniform acceleration, there are three equations of motion, which are also known as the laws of constant acceleration. Hence, these equations are used to derive the components like displacement, velocity, that is initial velocity and final velocity, time t, and acceleration k. Therefore, they can only be applied when acceleration is constant and motion is a straight line. So, when the body is moving along a straight line, then there are three laws of motion, or there are three equations of motion. First one is v equal to u plus at, which is the expression for final velocity. When we know the initial velocity of the body, u, and acceleration produced in the body, and time of turning, then we find the final velocity value v by using the values of u, a, and t. Another equation also for final velocity is v square equal to u square plus 2as. If we know the value of initial velocity u and acceleration produced in the body a and distance traveled by the body s, then we use this equation for determining the final velocity v, that equal to under square root v square plus 2as. And also another equation for displacement traveled by the body, displacement covered by the body. If we know the initial velocity u and time of journey t and acceleration produced in the body, then displacement covered by the body is found out by using the equation s equal to ut plus half at square. So here s is displacement, u is initial velocity, v is final velocity, a is acceleration, t is time of motion. These equations are referred as SUVAT equations, where SUVAT stands for displacement, initial velocity, final velocity, acceleration, and time. Now we shall derive the equation of motion. So equations of motion, first one, v equal to u plus at. That is, let us begin with the first equation, v equal to u plus at. This equation only talks about the acceleration, time, the initial and the final velocity. Let us assume a body that has a mass m and initial velocity u. Let after time t, its final velocity becomes v due to uniform acceleration a bar. Now we know that acceleration is the rate of change of velocity. Therefore, acceleration is equal to the change in velocity by time taken. So change in velocity means final velocity minus initial velocity. Therefore, acceleration equal to final velocity minus initial velocity by time. That is rate of change of velocity. Therefore, a bar is equal to v bar minus u bar by t, or at equal to v minus u. Therefore, v equal to u plus at, or v bar equal to u bar plus a bar t. Because v vector, u vector, a bar is vector, time is a scalar. Therefore, v bar is equal to u bar plus a bar into t. Now, another equation of motion is v square equal to u square plus 2as, or v square minus u square equal to 2as. We know that v equal to u plus at. So we can write t is equal to v minus u by a. And we know that displacement is equal to average velocity into time. Therefore, if a body covers as displacement in time t, then therefore for constant acceleration, we can write average velocity equal to final velocity plus initial velocity by 2. That is v plus u by 2. Hence distance is equal to s equal to average velocity into time, that is v plus u by 2 into v minus u by a, or s equal to v square minus u square by 2a, or 2as is equal to v square minus u square. Therefore, v square equal to u square plus 2as. Or by taking the first equation v equal to u plus at by squaring on both sides, then also there is an alternate method after we know the derivation of expression for s equal to ut plus half at square. Now we shall derive expression for displacement. This is another equation of motion. So let us derive the expression for displacement covered. Yes, we know that the distance is equal to average velocity into time. Average velocity is equal to v u plus v by 2. Therefore, distance is equal to average velocity into time. Therefore, u plus v by 2 into t. But from the equation v equal to u plus at, here by substituting the value of v, therefore u plus, instead of v, we substitute u plus at, therefore u plus at by 2 into t, or 2u plus at by 2 into t. Therefore s equal to 2ut plus at square by 2, or 2ut by 2 plus at square by 2, or s equal to ut plus half at square, or we may tell us s bar equal to u bar t plus half a bar t square. Now let us know another equation of motion, that is expression for distance traveled by the body in the nth second. So when a body starts initially with zero velocity or with initial velocity u, then for example its journey time t equal to n seconds, then let us calculate the distance traveled in n minus 1 seconds, that is AB, and distance traveled by the in the nth second is obtained by AE minus AB, that is DE. So yeah, distance traveled by the nth second Snth is equal to distance traveled by the body in 10 seconds minus distance traveled by the body in n minus 1 seconds. It is equal to u plus a by 2 into 2n minus 1, or Sn is equal to u plus a into n minus half. It is obtained by integration method. Acceleration is equal to rate of change of velocity, that is change in velocity dv by change in time dt. Delta v equal to the integration 0 to t a dt. So finally we obtained the expression for distance traveled by the body in the nth second. Sn is equal to u plus half into a into 2n minus 1. Next, let us know about acceleration due to gravity. What is acceleration due to gravity? Acceleration due to gravity is the acceleration that is produced in the object due to the gravitational force. So when we project any body into air, then as it moves up, its velocity gradually decreases because gravitational pull is towards the center of the earth. Similarly, when the body falling from maximum height to the earth, its velocity gradually increases from 0 and gradually increases as the gravitational pull is acting towards the center of the earth. So its velocity gradually increases 9.8 meters per second when it is moving down. When it is going up, its velocity decreases by 9.8 meters per second for every second. So this acceleration, positive acceleration or negative acceleration, is produced in the vertically projected body due to gravitational pull. So it is known as gravity, acceleration due to gravity. So acceleration produced in the freely falling body due to the gravitational force is known as acceleration due to gravity. Its SI unit is meter per second square, and it has magnitude as well as direction. It is therefore it is known as vector quantity. Its direction is towards the center of the earth. We represent acceleration due to gravity by the symbol small g bar. Its standard value on the surface of the earth at sea level is 9.8 meters per second square in SI system, and its computation value is based on Newton's second law of motion and Newton's law of universal gravitation. The acceleration due to gravity formula. Near the surface of the Earth, the acceleration due to gravity is approximately constant, but at large distances from the Earth around the planets and moons, it is varying. The acceleration due to gravity depends on the terms as the following: mass of the body, distance from the center of mass, universal gravitational constant capital G. Then small g is equal to gm r square, gm by r square, where g is acceleration due to gravity, capital G is universal gravitational constant, m is the mass of the Earth, capital M, small m is mass of the body, r is the distance from the center of mass of the large body. Therefore, small g equal to capital G into capital N by r square, where r is nothing but radius of the Earth. Now, g value changes with certain factors. When we go to up, as the height is increasing, then its value gradually decreases. So from the formula, g suffix h equal to g into 1 plus h by r minus power minus 2. This is the equation shows how g value changes with height or altitude. So g is the acceleration due to gravity at surface. Gh is the acceleration due to gravity at height h. R is the radius of the Earth. Small h is the height from the Earth's surface. It is clear that value of g decreases with an increase in height of the object. Hence, the value of g becomes 0 at infinite distance from the Earth. Now, example. The radius of the moon is 1.74 into 10 to the power 6 meters. The mass of the moon is taken as 7 into 7.35 into 10 to the power 22 kg. Then let us find acceleration due to gravity on the surface of the moon. So in this example, on the surface of the moon, the distance to the center of the mass will be same as the radius. Is r equal to 1.74 into 10 to the power 6 meter. Mass of the object, that is moon, m equal to 7.35 into 10 to the power 22 kg. And 6.673 into 10 to the power minus 11. The acceleration due to gravity on the surface of the moon can be computed by using the formula as below: g equal to gm by r square. Substituting the values given in the example, here we obtain the acceleration due to gravity as 1.62 meter per second square on moon. So the value of acceleration due to gravity on moon is 1.620 meter per second square. Here, therefore, when the body moves up, its value decreases, and as the body moving up, and when the body is falling from certain height, then as it moves towards the ground, it is attracted by the earth, so its value increases. So mass of the earth or moon here is the important factor. So the g value changes depending upon mass. But here on Earth, G value is 9.8 meters per second square. Therefore, we take their constant value when it is not specifically mentioned. G equal to 9.8 meters per second square in SI system. In CGS system, G is taken as 980 centimeters per second square, and in SI system, G is taken as 32 foot per second square. And this G is the important factor in determining the equation of motion when the body is moving under the influence of gravity. So, when the body is moving up, G value is taken as negative because gravitational pull is acting in the vertically downward direction towards the center of the Earth. When the body is falling from certain height from the Earth, and when it falling towards the Earth, then acceleration A is taken as plus G because here its velocity as the body is falling from certain height, its velocity gradually increases. That is at the rate of 9.8 meter per second square per each second. So here acceleration is taken as positive, that is plus G. So when the body is moving up, acceleration is minus G, acceleration due to gravity. When the body is falling down, acceleration due to gravity is taken as negative, minus G, that is minus 9.8 meters per second square when the body is moving up. When the body is falling down, G is taken as positive. So acceleration is equal to plus G equal to 9.8 meter per second. And when the body is moving in the vertical directions, then the equation of motion are changed in terms of G. So when the body is moving up, when the body is projected with certain initial velocity u, then u equal to u and a equal to minus G, and T is T, then V equal to U minus GT. So first equation for final velocity changes to V equal to U minus GT. Similarly, expression for displacement covered S equal to UT plus half AT square changes as S equal to UT minus half GT square because A equal to minus G and the body is moving in the upward direction, then it changes as S equal to UT minus half GT square. And when the body is falling down, its G value is positive. Now, when the body is moving up, the equation V square minus U square equal to 2AS changes as V square equal to U square minus 2GS, or V square minus U square equal to minus 2GS. And distance traveled by the body in the nth second, Snth is equal to U plus A into N minus half change into U minus G into in brackets N minus half. And or this equation may be written like this: Sn is equal to U minus G by 2 into in brackets 2n minus 1. Now, when the body is falling from maximum height where its velocity is 0, and when it is falling towards the Earth, then as it is falling down, its velocity gradually increases. Therefore, it is here in this case acceleration is taken as positive. Therefore, A is equal to plus G. But as we take the At certain height, its velocity is 0, initial velocity u equal to 0, then the equation of motion becomes u s equal to ut plus half of at square becomes s equal to half gt square since e equal to 0. Similarly, v equal to ut plus at becomes v equal to gt by substituting u equal to 0 and a equal to plus g, we get u equal to v equal to gt. And third equation, s equal to g, v, v square minus c square equal to 2as becomes v square equal to 2gs. So, and expression for distance traveled by the body in the nth second becomes Sn is equal to u plus g by 2 into 2n minus 1 becomes, as u is equal to 0, Sn is equal to g into in brackets 2n minus 1, or Sn is equal to g into in brackets n minus half. So these are the equation of motion under gravity. So let's discuss in detail the equation of motion. So here, when the body is projected with certain velocity into air in the upward direction, then as it moves up, its velocity gradually decreases. Therefore, as the body moves up, its velocity gradually decreases. And as it moves up, for every second, its velocity decreases by 9.8 meters per second for every second. And finally, its velocity gradually decreases, and at particular height, its velocity becomes 0. Then the body is said to be reach the maximum height. And when the time taken by the body to reach the maximum height is called time of ascent. So time taken to reach the maximum height from the earth is called time of ascent. And after reaching the body to the maximum height, then its velocity becomes 0, and the further it does not advance in the upward direction. And as the body is pulled towards the center of the earth due to gravitational pull acting towards the center of the earth, so the body starts falling down and moving towards the earth. So again, it reaches to the earth. So the time of ascent is equal to, in this case, time taken to reach the ground is also same. So the time taken to reach the ground from the maximum height is called time of descent. So here, when the body is projected vertically upwards from earth, the time taken to reach the maximum height is called time of ascent. And when the body returns from maximum height to earth, from starting 0 velocity, then the time taken by the body from maximum height to reach the earth is called time of descent. The total journey time is called time of velocity. The total journey time is called time of flight. Therefore, here, time of flight means total journey time, that is time of ascent plus time of descent. That is called total journey time or time of flight, limited by capital T. So in this class, we know the introduction of dynamics, in which we know the every body has two states. Either every body must present either in rest or in motion when compared to the surroundings. So if the position of the body does not change with respect to time and surroundings, then it is said to be in rest. And if the position of the body changes with respect to time and surroundings, then it is said to be in motion. So the body must be either in rest or in motion. Generally, when applied some force, then only the body changes from rest to motion or motion to rest. These rest and motion are two relative terms, but here all the objects are in motion when compared to in sun. Then we all are along with this earth moving around the sun. But when we compare it to our surrounding objects, when we sit in a chair, then I am at rest when compared to other objects. But if I sit in the bus also, when it is not travel starts the journey, then I am also at rest. But when the bus is started, then when compared to other passengers, I am at rest. But when compared to the surrounding trees, other objects, they seems to be moved, but actually bus is moving along with all passengers. So bus is in motion and passengers are in motion. So when the body moves from one place to another place, then it will be at certain positions as the time goes on. So when we join the line with the successive positions of the particle at different timings, then we obtain the path traversed by the particle or body, moving body. So this total length of the path traveled by the body is called distance, because it does not have the particular direction. It is called distance. It is a scalar quantity. But when the body moves in a particular direction, then the total length of the path is called displacement, or the shortest distance between 2 points is called displacement. Now we know what is meant by speed and velocity. So the change of position of a particle in a particular time is known as speed. The rate of change of position of a particle in a given time interval is called speed. The rate of change of displacement in a particular direction is called velocity, or rate of displacement is called velocity, or velocity is equal to displacement covered by time taken. And both displacement and distance measured in same units, that is in SI system meter, and in CGS system centimeter, in FPS system foot. And dimensional formula is L for distance and displacement. So when we consider the speed and velocity, both are having same units and dimensions. But speed is a scalar quantity. It does not possess any particular direction. But velocity is a vector quantity. It possesses a particular direction. So the dimensional formula for speed is L to the power of -1. Velocity also possess the same dimensional formula lt to the power minus 1. And in SI system, the units for both velocity and speed is meter per second, and in CGS system centimeter per second. In SGS system foot per second. And when the velocity of the body here does not change with time, that means it is said to be moved with constant velocity, and this velocity is said to be uniform if the body covers equal displacements in equal intervals of time, and if the body does not cover equal displacements in equal intervals of time, or if the body covers equal displacements in unequal intervals of time, then the body is said to be moving with non-uniform velocity. So if your body moves with uniform velocity, then there is no change in velocity. It does not possess any acceleration. Its acceleration is said to be 0. So acceleration is defined as the rate of change of velocity. So when there is only change in velocity, then only the body possesses acceleration. So acceleration is defined as the rate of change of velocity. That is, acceleration is equal to change in velocity by time. If your body starts with initial velocity u, and if its final velocity is v after time t, then acceleration of the body is obtained by dividing the change in velocity with the time, that is final velocity minus initial velocity by time, that is v minus u by t. Therefore, a bar is equal to v minus u. Body gradually increases, then its velocity is said to be positive acceleration. So when the body is said to moving with positive acceleration, then it's moving with increasing velocity. So when the velocity of the body decreases, its velocity is decreasing, it possesses negative acceleration. Therefore, here these are the important terms. So in this projectile motion, when the body moves in the horizontal direction, then it is said to be in horizontal projection. That shall discuss in the next class.